the diagram shows a sign attached to a point A by a light rigid rod AB. It's supported by two light rigid rods AC and AD, making angles of 60 and 40 to a vertical post respectively, as shown in the diagram. The mass of the sign is 25 kilograms. Find the forces in the rods AB, AC and AD, stating whether they are in tension or compression. Okay, so here is the original diagram. So drawing a diagram of forces acting just on the sign. So we'll draw a sign. We're weighing 25 kilograms. So we got the weight acting down 25G and the tension TAB. If we resolve that, and because the whole thing is in equilibrium, TAB is going to be equal to 25G, which is equal to 0. And therefore TAB will be equal to 25G. Now we're going to, which gives you, 245 newtons. So now what we're going to do, that will obviously be in tension. Now what we're going to do is we're going to draw a diagram of the forces acting at the joint A here. Right, so we've got the tension acting downwards, TAB, that we know that's in tension. We've got a force here and a force here. So TAC will definitely be in tension. Now we've got a problem here. Which way do we put the arrow on this force here? If we put it the other way, when we do the horizontal components, nothing will be in balance. You're going to have two components going that way, and therefore the whole system will not be in equilibrium. So this one force has got to be in compression, and this force here has got to be in tension. Right, we need to find what this angle is. So if we draw the little triangle in a right angle triangle, so we've got 50 plus 40 makes 90, that makes that one 90, so that has to be 50, and then this one will have to be 30 because this one is 60, just using two right angle triangles. Right, we can now, resolving vertically, so we're resolving this way, we're going to have TA sine 30, which is this component here, plus TA sine 50, which again is acting this way because we put the arrow this way, is minus 25G, minus the one that we just found here, is equal to 0. We'll call that equation 1. Resolving horizontally, we're going to have TA cos 50 acting this way, and we're going to have TAC cos, TA cos 50 acting this way, and then TAC cos 30 acting this way. If we put the arrow here the other way around, then we're going to have two forces acting in this direction, and the whole thing won't be in equilibrium. Right, we can now, from 2, we can rearrange it to say that TAD is going to be TAC cos 30 divided by cos 50. So writing that down again, and we now substitute that into equation 1. Equation 1 was this: TAC sine 30 plus TAD sine 50 minus 25G is equal to 0. So carefully substituting in, so we've got TAC sine 30, so we're going to replace this here now, so I've replaced it in red. TAC cos 30 over cos 50. Don't forget there's another sine 50 there. Minus 25G, which we've taken over to the other side now because this is equal to 0. Right, making a common denominator of cos 50, which means I need to multiply this by cos 50, the common factor of TAC that's come out. Sine 30 cos 50, cos 30 sine 50, is equal to 25G. Now you will know that sine A plus B is sine A cos A sine B, which is what you've got here. So you're going to have TAC, it's got sine of 80, so 30 plus 50, using this, over cos 50 is equal to 25G. And then rearranging that for TAC, we're going to have 25G cos 50 over sine 30. And we've worked that out on our calculator. We get 159.912, which gives me 160 newtons. And as I said, this force here is in tension. From equation 2, which is this one here, we've rearranged it a little bit, but we'll use this one here. If we now substitute in TAC, we're going to have TAD is 159.912. Don't use one that's been rounded off. Cos 30 divided by cos 50. On my calculator, that will give me 215.449, which is 215 newtons. And as I said, this force here will have to be in compression. And that makes sort of sense, doesn't it? This is pulling down, this has got a tension here, so this will be in compression here. Okay, so this has been a video to show you how to resolve forces in a sine. I hope you've understood, and I thank you very much for watching.